Okay, we're going to be starting lesson 10.6. This is the problem solving lesson, so we're going to do problem solving on this is problem solving strategies. And this is page 505. We're working on this together. So starting with number 1. We're going to break all of these into small parts. So we're talking about a neighborhood party, and we're going to use the table below to find the total cost for 100 people to attend a 3-hour neighborhood party. So what is our question? We want to know the cost for 100 people for a 3-hour party. That's what we're trying to figure out. And we have a table of information. We are going to have a tent, a band, and dinner. So we say that found out that our tent, it costs $250 for 3 hours. So we know our tent's going to cost $250. We have a band that is going to cost $150 for 1 hour, and we have a dinner that is going to cost $20 per person, for every person. So we want to know the cost of our tent, band, and dinner. So for 100 people. So since it's a 3-hour party, our tent is going to be $250. That's a straight cost. We find out that our band at $150 an hour, so we're going to multiply that times 3. So $150 times 3, 3 times 100 is 300, and 3 times 50 is 150. So the band is going to cost us $450. And then our dinner is $20 per person, so 100 people times 20 people, or $20, is going to give us a total cost of $2,000. So we are going to now just add that up. So the cost of the tent, the band, and the dinner, if we add all that up, we're going to get $2,700, and then we have another 100 added on to that. 50 plus 50 is 100, so $2,800 for this party. And I think I added this up wrong. And yes, I did add this up wrong. It was 226 right there, and so it's $2,700 for the party. So $2,700 for this party, and we'll box that in. Let's go to number 2, skip a line. We're talking about a museum price. How much is it going to cost for this group to go into the museum? So we want the total cost for, we have 2 adults, we have 2 students, and 1 senior, and 1 preschooler person. So again, we're trying to figure out what the total cost is, so little chunks at a time. We find out that our adult tickets are, if we take a look at our table, the adult tickets are $10. So it's 2 times 10, which is equal to $20. That's for our adults. And then we have 2 students, and the cost of the students, if we look at our table, it's times $5. So we say, okay, what is 2 times 5? And of course that is 10. And then we say, okay, we have 1 senior. The senior tickets are $7, so it's $7 for the senior ticket. And the preschooler is times $2. So it's $2 for this preschooler ticket. And then, of course, we want to put those together. So we have 20 plus 10, that's 30. 30 plus 7, 37, 38, 39. So our total cost for this group is $39. Number 3, we have a ramp we want to carpet this ramp, and so we don't want to carpet the bottom, however. So we want to carpet all the sides of the ramp except the bottom. It's a triangular prism. So how many square yards, feet of carpet do we need? So let's draw this shape first. And we're going to make a slanted line, as we want a really slanted parallelogram. So slanted line. And then we want to connect those two sides. So that's the top part of our ramp. And then this is a triangle. So we're going to put the base of our triangle there. And then the end of it is a rectangle. So there we go. Let's draw that first. And then we want to label this as 13 feet and 12 feet for the base of the triangle here, and then 6 feet and then 5 feet. And we want to know how much carpet are we going to need to cover that whole thing. So the first thing we want to do is we want to find the area of just this top ramp part. The top ramp part. And since the length is 13 feet and the width is 6 feet, so length times width, 13 times 6 in this case. I'm going to zoom this in just a tad so you can see a little better. There we go. So 13 times 6, and of course that's going to make, you can use your calculator on these, but 6 times 10 is 60, plus 18 is equal to 78. So that is the top part of the ramp. I'm going to refocus this real quick. Again. There we go. Much better. Okay. Then we're going to take a look at the triangle, and we have, so just keep that separate for right now. And then we want to take a look at this triangle. What is the area of this triangle? So we have the area of the triangle, we have the base, and usually the area is 1/2 times base times height. So the base is 12, and the height of this triangle is 5 feet. So base of 12 and height of 5 feet. So 12 times 5. And if you know your basic facts of 12 times 5, you know, of course, that is 60. But since we have this triangle, and then we have the triangle on the opposite side, we're not going to cut this in half, because we're going to have two triangles. So we're going to, rather than cutting in half, we're going to, and using this as a triangle, we're going to leave that because we're going to have two sides. So 60 for both of those triangles. Keep that off the side. We'll just kind of circle that. And then we want the area of this end here. And of course that area is equal to length times width, and we have 5 times 6, which of course is equal to 30. And then we want to put all three of these parts together. So we have 78 for the top part of the ramp, and then we have 60 for the two triangles on both sides, which will give us 138. Then the carpet on the end, so add 30 more, and we're going to have 168 feet of carpet. And so we want to, and this is area, so we want to make sure we square that. So we're going to need 168 feet squared piece of carpet. Number 4, we have this border. We want to put metal border on this stained glass. So we're going to take a look, and we're going to outline put our drawing down. And our stained glass pieces, the sides are 36 inches, and the ends are 24 inches. So not that end, but this end is a half circle. So we're going to find out how much do we need around the whole outside edge. So kind of all the way around this part right here. If you color that in, we want all the way around this part right there. So we want to see how much of that metal border we're going to need. And if we take 36 and 36, we add those together, we're going to get, of course, 60 plus 12, which is 72. So 72 inches with the two sides, and then we're going to add on 24 for the end, which is going to give us 96. But now we need to figure out this part on the end, this half circle, and that we want the circumference, we want the distance around it. So we want to find the circumference of the circle, and our circumference is pi times diameter. Pi times diameter. Now the diameter of this circle, since the diameter is 24, we're going to just mark that down. So pi times diameter, pi of course is 3.14 times the diameter, which is 24. So take your calculator and figure that out. 3.14 times 24, you're going to get about 75 something, or something close to that. 72, 75. If you punch it into your calculator, you should get, I believe, 75.36. Now keep in mind this is only half of a circle though. So we want to now do what? If you said cut it in half, you're exactly right. So we're going to divide it in two. Take your calculator. Take your 75.36 and divide that by 2, which will give us 37.68. 37.68. So we want to now take that 37.68 and we're going to add that on to 96. So I'm going to say 96 plus 37.68. Add it up. And that should give you, let's see, 30 plus 90 is 120. 7 plus 6 is 13. That's 133. And then plus 60.68. So we end up with needing, for an outside edge of the metal needed, we need about 134 inches. About 134 inches of metal. Going on to number 5, we have a spinner, and we're going to spin the spinner below 2 times and then add the numbers that we get. How many different sums are possible? So we're going to take our spinner and we're going to spin the spinner 2 times. So we get a 1, 2, 3, and 4. So if we spin the spinner 2 times, let's say on the first time we get a 1. And let's say on the first time again, if we spin it again, let's say we get a 1 again. So if we add those 2 together, we get 2, because we want to find the sum of the 2 spins. We could get a 1 and a 2. And if we add those together, a 1 on the first time, a 2 on the second time, that would give us a total of 3. We could get a 1 on the first time, and we could get a 3 on the second time, which would give us 4. We could get a 1 on the first time, and we could get a 4 on the second time, and that should give us a total of 5. Let's see what other possibilities exist. Let's say on the first spin, we did it get over, and we say in this first spin we got a 2 on the first time. So what are our possible combinations getting a 2 on the first spin? Well, we could say a 2 and a 1, which would give us 3. We could get a 2 and a 2, which would give us 4. We could get a 2 on the first spin and a 3 on the second spin, which would be 5. We could get a 2 on the first spin and a 4 on the second spin, which would be 6 if we added them up. And what if we get a 3 on the first spin, a 3 and a 1, and then a 3 and a 2? That would give us a 4, and then it gives 5, a 3 and a 3, which would give us a 6. Keep going. We'll finish this out. Now we want to know how many total sums we get. We get a 2, 3, 4, 5, 6, 7, and 8. That's 1, 2, 3, 4, 5, 6, 7. 7 total different sums. So 1, 2, 3, 4, 5, 6, 7. 7 sums. Box